We've talked a little bit about the mathematics, or maybe the intuition would be a better word than mathematics. The intuition behind covariance or analysis of covariance when we talked about multiple regression. And so some of that will come up again, but then there's some new stuff here that we'll look at. I don't think it will take us the entire hour. Well, I'm certain it won't take us the entire hour to get through this, but we're going to, once we're done with this, we're going to start on the chapter 7 from your textbook, multivariate analysis of variance, and get as far into that as we can, and then we'll be in a good place for next week. So analysis of covariance is used to, again, test for main and interaction effects, just like Bobby had mentioned a minute ago regarding ANCOVA, but at the same time controlling for the effects of some selected other group of variables or covariates. It can be a single factor. What's a single factor ANCOVA? Single factor ANCOVA is what? Single factor ANCOVA is what? Huh? Yeah. So single, yes. Yeah, and so another, I think one-way ANCOVA and single factor ANCOVA would be the same. And multi-factor ANCOVA could be two-way or three-way or something greater than one. So it doesn't have to be. It can be any of the designs that we've talked about so far. The ANCOVA can increase the sensitivity of our test by reducing the within sums of squares. So if the covariates are selected in such a way that they reduce with the within group variation, that would be a good thing, because remember the ANCOVA is between divided by within, and so if we can reduce the within, even if our between stays the same, our F value would be greater, all things being equal, right? So that's some of the thinking behind ANCOVA, is that we can reduce that within group variation. But just as in many things, it's not foolproof. And in my experience, usually when you reduce within group variation, at the same time your between group variation also takes a hit, and so you end up with a F value that is similar in size to what you would have had, but you also, because the ANCOVA uses degrees of freedom, you have fewer degrees of freedom, which makes it more difficult to find significant effects. So it is not a sort of free lunch to finding significant results. It sometimes can get us there if it only is reducing the within group variation, but that isn't foolproof. And then ANCOVA can be viewed as asking, what if all of your participants scored equally on the covariates? And so whatever that group of covariates are that you're using in your analysis, essentially we're controlling for those, and we're answering the question, what if everybody scored equally on whatever that group of variables are? And so just as a motivating example from last week, remember the DV was how much people trusted the media? And one of the independent variables was political party identification. Are you a Democrat, Independent, or Republican? And the other independent variable was male or female. And we could examine this same data, and in fact we will, with what I would call several meaningful covariates, and meaningful in quotation marks, meaning that theory or past research would suggest their inclusion. So age of participant, levels of education, how interested they were in political campaigns or a specific campaign, how much attention people pay to the news, how pessimistic or optimistic of a person are they, or how much they talk to other people about politics. So we could do this very same analysis and control for those variables, and then we would have a bit stronger claim to make regarding our analysis. We could say that party identification is still a significant factor, even holding levels of education constant, or how interested people are in the campaign constant, or how optimistic or pessimistic the person was about the country. And so that's a bit stronger claim than not than if we weren't including those. Why do you think we'd be able to make a stronger claim? Why do you think our argument would be a bit stronger if we included this group of, or in fact any group of covariates? Why would we be able to more strongly, or maybe be more persuasive in our argument that we're making? Michael?
Well, you can say that you can control for those. So you, like your argument, you can say we looked at all of these covariates, and while we controlled for those, we still have a significant effect, and there's no spuriousness. Is that the word?
Yeah, I don't know where spuriousness is the word, but I'm not quite sure how that everything was. I followed everything until you inserted the word spuriousness, and then, but I understand. Yes, that's exactly what I think that makes sense. Save the word spuriousness. No. So, for example, if somebody says, "Well, you know what? I don't think it's party identification that matters. I think it's because Republicans tend to be older, and older people tend to be more trusting or less trusting of the media." But they can make one of those two, right? Republicans tend to be, they don't think it's party identification. They think it's age, because Republicans tend to be older, which is the fact. And older people tend to trust the media more than younger people. I don't know if that's a fact or not, but I'm just saying hypothetically. And if they were going to make that argument, we would be able to say, no, it's not age, because we've controlled for age. We've set, or education. Maybe people who are educated, we become critical thinkers, right? Isn't that what we're doing here? We are, as teachers, we're teaching students to be critical thinkers, right? And as we become more critical, how can we not become less trusting of the media establishment? And so somebody might say, well, it has nothing to do with party ID or whether somebody's male or female, but it has something to do with levels of education. And Democrats tend to be more educated than Republicans, and so it could be that's the difference, and it's not the party identification. And again, we could say, no, that's not true, because we're controlling for education. Does it make sense? One thing that I find important when you do decide to use covariates in your analysis, you need to make some argument for why you're going to include them. And this is a bit cynical. Well, it's just cynical, but it is my experience. People will run an analysis, find non-significant results, and then hunt for ways, look for ways to, because non-significant results tend not to get published, right? And so we and I'll include myself in this just for the sake of being inclusive. We then look for ways to find significant results, and so, well, let's add in a couple covariates. Let's see what I have. What did I collect for this particular study? And the reason I think the reason that seems that people do that is when you read their research, that's how it reads. They talk about this elaborate experimental study that they're doing, and then they get to their results, and they have all of a sudden inserted 4 or 5 control variables or covariates without any explanation as to why they were needed. And I really don't know what to think about. How did they end up there? It seems to me that there should be some rationale behind why they were included, and I think in more cases than not, they were included because they were just on a hunt to find. And so let me just input some additional covariates and see what happens. And if something happens to work for them, that ends up being what gets in the document. And I would say this is more conference papers, dissertations that I've read, as opposed to peer-reviewed research. Because I think part of the peer review process, when it's done well, will please make an argument for why you need to include, these covariates, and that can be fixed if there's a decent argument to be made. Michael?
Why would that be a problem to just add like a ton of covariates? And because I mean, if they're significant, they're significant, right?
And so I think it's a problem if what happens is if you approach the research problem saying, I need to include a ton of covariates, which I don't quite know what number that is, but I need to include a ton of covariates in this analysis, and then you run your analysis that way, I'm good with that. I think that where there's a disconnect, or at least some issue, is where it's done, it's sort of post hoc theorized, right? We do the analysis, we don't find what we're looking for, we don't want to just, okay, I spent 3 months collecting that data, and my tenure decision's coming up, and I guess I'll just take another 3 months and collect some more data, and hopefully not have it. Right? We're motivated to try to find ways to fix the problem of non-significant results, and that's one way I know for a fact that people will sort of fish around with, and it's sort of that aspect of it that I don't think it's a fatal flaw always. It seems like in some cases it might be, but I think that's the concern. It's sort of post hoc, okay, what can I do to fix this? That kind of thinking that I think leads to the concern. Does it make sense? Mm-hmm. So far, so good? So would I be able to make a stronger causal argument here with this data? Would I be able to make a stronger causal argument that party identification leads to levels of mistrust in the media, or males and females, or the intersection of those two? Would I be able to make a stronger causal?
You should be able to, because basically you're saying, look at the numbers. It's not this, it's not this, it's not this, but it's showing up here, so it's got to be party identification.
Or is this everything?
No, it's not everything, but you're at least saying it's, here are all these different items we've tested for, and it's not that.
But you can't make a causal argument whenever you have survey data. You can only make a causal argument with an experiment. Because you don't, there's a temporal aspect.
Well, you can do a longitudinal survey.
You could say trust in media becomes first, and therefore you identify with the party.
Sure, and this doesn't untangle, adding in those covariates doesn't untangle the so-called chicken and egg or causality direction question. And we can't make...
You can't make causal arguments on the survey data. Definitely not cross-sectional survey data. There's still lots of other things that could Right.
affecting that relationship.
Right.
Then you have to test.
But would we be able to make a? Is there such thing as a? Well, we wouldn't be able to. I mean, could we make a stronger causal or stronger than we did before, without? So if I just did the straight up survey data with just the analysis that we looked at last week, and that was option 1, and then option 2 was adding these covariates. Am I in a better position to make a causal argument?
That's a slippery slope.
No.
Why is it slippery?
I think you can say that it's more likely that there might be a causal argument, or that there might be a cause-effect relationship going on, but I don't think you could ever even try to make a causal argument with that kind of data. You can say that they're definitely related, and we can definitely say that there's a strong argument for a relationship there. And because we control for these different things, then there might be a causal argument. You could.
Or at least it's not caused by these things, right? It's not age that's causing it. It's not education. It's not these things that are causing the increase in the differences between. Yeah. Brianna, what do you think?
I think you can make a stronger argument towards causality.
Good. I like that, and but it's still going to be tempered by the limitations of our data, right? I don't know. I wouldn't even use the C word. Does anybody?
That's what's bothering me.
I wouldn't use it.
I wouldn't use the C word either, right? And because you're only asking for trouble, even if you have the best experimental study and you've spent 6 months designing the thing, I would not use the C word because you're only going to get yourself in trouble. Somebody's going to say, even if you have an experiment, right? Somebody's going to say, well, how about this threat to the internal validity of your study? Have you considered it? And there would always be, personally, I wouldn't go there. I might say something similar to what Aaron talked about, that we could just sort of walk up to that point, and we've ruled out that it's these other factors. Of course, there's other factors that we haven't ruled out. Keep that in mind. But I think we'd be able to make a slightly more convincing argument, although it certainly would not rise to the level of proving causality, which good luck trying to do that, because it's an impossibility.
The only other way to go about it is to, when you're writing it up, say, we control for all these factors. Of course, there could be, or there are many, many others that we did not control for, but at least we have given attention to all of these,
right.
And this is where our results go.
Or you could let the reader come to that conclusion on their own, right? You could say we've controlled for all of these things and look at the great work that we've done, and then just stop short of saying, therefore, party identification causes. Right. Yeah. So it does not allow you to make causal arguments with survey data. Although I think people try to get that out of the process if they can. Maybe before we go there, what would be another example of using covariates? When would be another case where you'd use covariates in an analysis?
Well, if, for example, you want to train cognitive biases out of people and you design a video game to train them, you might covariate out gaming experience.
You should do that.
But for example, were the people randomly assigned to the game?
Yes.
Doesn't random assignment take care of that for you? Because then by random assignment should get you people with equal levels of experiences across the different conditions, right?
We had 2 sites,
Oh.
Oklahoma and Arizona, and we found a difference between the 2 sites.
And this difference was?
People in Arizona were in the MIS department, so they gained more frequently than people in Oklahoma.
And so in that case, when you're combining the data together, then that might be the place where you'd want to, because it really wasn't, well, it really wasn't, for the entire study, it wasn't, the random assignment was not perfect, right? It wasn't, because, not random selection, but the, yeah, for the big picture, if you combine both the sets. So that would be, I think that would be a good example of where you would want to, and that would strengthen your abilities to claim that the game led to the outcome of interest, reducing biases. Michael.
Well, for the NSF grant that we do, we made like ideological website like groups, and one of the covariates that we have is pre-attitudes, like about. We did one on immigration and on separation of church and state.
Yeah.
So if it was truly random, then it would be fine. But we live in Oklahoma, and so I think.
But it's not random selection, right? It's random assignment is what we care about, right? The random assignment probably was good, though, right?
Yeah. Well.
I mean, random selection is different than random assignment, right? And we're not, in this case, we're not talking. It's not random selection; it's random assignment that we care about.
I misspoke.
No, but so you covaried for
pre-attitudes.
Yeah. Because there was a concern with whether you did randomly assign people. Does that make sense? If we do randomly assign them, the pre-attitude shouldn't matter, right? Why shouldn't it matter? If random assignment works,
They'll be equally dispersed.
right, if we're just flipping coins or drawing straws, then the attitude across the groups should be not, are they going to be exactly equal? Of course not. But they shouldn't be significantly different from one another.
Yeah.
Just by chance, right?
Is that the heteroscedasticity? Is that what that is?
No.
I'm still confused on that.
So that's Levine's test. Think Levine's test, and we're comparing.
Equality of variances.
Right, and so it's equality of variances is what if it's not equal, then it's heteroscedastic. And so I don't know how that plays into analysis of covariance. I'm sure it would, but it's, talk to me about what you're thinking.
I think I just need to think a little more.
About which one?
Equality of variances.
Okay, yeah.
Levine's.
Yeah, and it really is as simple as that we're assessing whether the standard deviations or the variances across the group are equal or not. And I guess if we're randomly assigning, then our variances should be equal, right? If something went bad with the random assignment, or we weren't able to, in some cases we can't randomly assign very well, right? Let's say we're doing a study with textbooks, and we're trying to study whether new textbook matters in terms of math achievement. You can't very easily have a classroom where the students are using two different textbooks, right? You'd have to randomly assign whole classes of students to either the experimental textbook or the control textbook. And in that case, the random assignment isn't as good as you probably would want it. So in that, it would make sense to potentially, and you could have heteroscedastic issues and potentially co-varying out some of the, different, maybe one of the schools are in a higher socioeconomic status area or greater percent of males than females or whatever you'd want to.
I think that was kind of my thought process.
Yeah.
Like with true random assignment, your data should be
True.
Skedastic.
True, yes. Just like with true random assignment, the differences on any variable of interest should not, other than what's, assuming the null hypothesis is true, the differences should be not greater than we'd expect to get by chance, right? And so I think random assignment in most cases takes care of the need for covariates, but what would the thinking be? Why would you still want to include, what would be an argument for still including a covariate, even though we did random assignment and it worked really, really well? Is that, were you raising your hand, Cameron, or just scratching your head?
No, I can tell you that we had to because the grant stipulated that you would covariate.
Oh, and did they give you a reason why, or just asserted that
We
they
had
should?
to covariate handedness.
Did they give you a rationale as to why?
Right-handed or left-handed.
In informal communication, he said, I thought that maybe some teams would design a video game that favored people who were right-handed.
Yeah.
But it never popped in our.
Well,
Well, it did.
computers in general are designed for right-handed people.
Are they?
Well, with like the mouse on the right hand, the right side is, and like the left clicking for the index finger.
There's
Oh,
one
yeah.
reason though.
Clipboard and keyboard isn't though.
I'm left-handed. I'm good with the.
But just think how good you would be.
I know. Thanks. So in your case, they stipulated what would be another good argument to make for we did random assignment, it worked out. We flipped coins. We drew straws. We did a random assignment as you would expect. What would be an argument for why we still need to covary some factor?
I don't know.
What's that?
Individual differences?
But the individual differences should be equal across the groups, right? Because we've randomly put people into one of several groups, right? So the individual differences, whatever that difference is, age or gender or ethnicity, whatever it is, it should be, by chance, that's the key word, by chance, it should be not significantly different. So what would be an argument for
We
including?
don't want to take any chances.
Yeah, that's it exactly. So what would you do? We don't want to take any chances that our random assignment didn't work, right? Because it is random assignment. It could be that we just happen to get a bunch of left-handed people, but just by chance, a bunch of left-handed people in one of our, that's a possibility, right? And we think left-handedness really matters, and so we're going to make sure, we could actually test for that to see if the difference was significant, and if the difference was not significant, you wouldn't have to covariate. But let's say we didn't go that route, we just decided we wanted to put in the covariate. That would be the best argument I think that you'd have, the best argument that I can think of, just in case the random assignment didn't work. There is a chance that it didn't work, and so just in case it didn't work. But then you are using up degrees of freedom when you add in covariates, and so it's not a free lunch. There's going to be a price to be paid potentially in your analysis, Michael.
Do you have like a rule of thumb as far as like how many covariates you include?
Less than the number of participants, for sure. Greater than one, no, there isn't. I think theory would sort of, or in this case, this is data that was collected by another group, and we've analyzed it, and they collected these things, and these seem like meaning we could make a theoretical in quotation marks. We can make a theoretical argument as to why we included each of these covariates, and so that would be the determining factor, not some other number.
So what if it turns out that like age really is the thing that's driving it, and it's a covariate, but in reality that should be your.
You wouldn't know that from this analysis, right? All we would know is if we put age, let's say the analysis without the covariates is significant, we put age in, the significance would go away, and that's what we'd be left with. Unless you were to do some further exploration of, well, what happened? Why is it that our significant results, after we include the covariates, are no longer significant? What would theory say? What would be some potentials that we could look to for helping to understand why it went away. And then through that exploration, you might discover, hey, it really is age. It's not party identification or gender. Does that make sense? Other questions? So one or more covariates, again, theory or past research or available data would have to dictate what that number is. They can be, or they need to be, interval or dummy-coded categorical variables. So you can have categorical dummy variables, but you can have categorical covariates, but you'll need to dummy code them, as we've talked about previously. And this is the part that we actually touched on this when we talked about residuals and multiple regression. So the way that the intuition behind the way ANCOVA works, and this all happens behind the scene, you just insert variables, and this all takes place behind the scenes, is what it does is it regresses the dependent variable on the covariates, and then we run the ANOVA on the residuals. And remember that the residual is predicted minus the actual dependent variable. So mathematically, that is very close to what happens, where all we do is we run, or the machine calculates what's the residual for the dependent variable given the covariates, and then it takes that residual, makes it the dependent variable, and then runs the ANOVA, and then makes some adjustments for degrees of freedom. And then gives back to you an ANOVA table with those adjustments plus some information about which of the covariates were useful in your analysis. And again, this allows us to see if a factor is still significantly related to the dependent variable after the variation due to the covariates have been removed. And so this is something that I know I did something similar to this in class one day. This is just it in the context of the example that we're working with right now. So trust in the media is the dependent variable, and then these are the residuals that I had mentioned on the previous slide. And we can see that the correlation between the original trust in media variable and the unstandardized residual, again, remember the residual is just taking the actual minus the predicted. And the correlation is still quite high, right? 0.963. And so the original trust variable is still strongly correlated with the residual. And it's this thing here, this residual then, that becomes the dependent variable. And then along with that, we include our two independent variables, in this case, party identification and whether they're male or female. Again, this happens behind the scene. All we have to do is tell the procedure what we want for covariates, and it does all of this for us. But again, I think it's useful to understand a little bit about what's going on. And then, of course, I always find this interesting, that the correlation between the covariate and the actual residual is 0 for all of those covariates. And it's not approximately 0. It's exactly 0 to an infinite number of decimal places, which I find to be sort of a mathematical anomaly, something that is interesting. So if we use this value, this unstandardized residual, as our dependent variable. Can we say that the effect of age, education, campaign interest, and the other covariates, can we say that it's been removed? If we use the unstandardized residual as the dependent variable, can we say that the effects of the covariates have been removed? Why? What's your evidence for the effects?
Because there's no residual.
Because what?
Because there's no residual.
There's no residual, or there's no something residual. I might edit that just a little bit. What's the evidence that if we use the unstandardized, if we use the residual as the dependent variable, what's the evidence that the effects of all of the covariates have been removed?
There's no difference.
How do you know that? Yeah.
Said zero.
Right, but it's not a that's it. It's not a difference though. It's a correlation, right? The correlation is exactly zero.
Perfectly non-significant correlation.
Yes, it's a perfectly non-significant zero correlation between the covariates and the thing that we're going to use as our new dependent variable. So how can you not claim that the effects of those things have been removed from this? I don't know mathematically how you can make that case. One potential argument might be more methodological in nature. What would be a methodological reason why, a more methodological reason why this might not be absolutely true? That we've completely removed the effects.
Maybe your measurements aren't measuring exactly.
Perfect.
what you-
Yeah, right. So to the extent that we have measurement error in our covariates, all it's doing is taking the data that we're giving it, and if it's not reliable and or not valid, then there is then this number doesn't mean a whole lot. So if our measure of attention to news is not a reliable measure, then who cares about this? So I think that's useful to keep in mind. It's not free of all of the methodological issues that we have in other research contexts. Just because the correlation suggests that it's zero doesn't mean that this phenomena, political discussion, for example, has been completely removed. It's only been removed to the extent that that thing measures political discussion. All right? And I guess I highlighted that 0.568 because it's the highest correlation. Is that, I assume that's what I was thinking. It's the highest correlation on the table. And one of the considerations that I'll mention in a little bit is that multi-collinarity, or collinarity is an issue with covariates. And so I was just pointing out that that potentially could be a problem. There it is. There isn't a test as readily available for analysis of covariance. Remember the tests we used for regression? What were the collinarity tests that we used for regression?
Variance inflation factor.
One of them is variance inflation factor. What's the other one that we use?
Random syntax. Random syntax.
Parallel analysis.
What?
Parallel analysis.
Yeah.
What is it?
Parallel analysis.
No, that's
What
oh. Parallel analysis is what we did for factor analysis, right?
Condition indexes.
Yeah, and then there's another one. So in the regression table, it lists variance inflation factor, in the far,
Dollars.
yeah.
Those are the same thing.
And so those two, variance inflation factor, and what's the other one? No, tolerance. Tolerance and variance inflation factor are not readily available, although we could probably calculate them easy enough if we were so inclined. Probably a pretty good rule of thumb. If a couple covariates are correlated greater than 0.7, you might want to just assess, do you need to absolutely include both of these, or can you just rid the analysis of one of them? It would alleviate any potential concerns. All right? And so this is the thing that we sort of already talked about some, that some, I think one issue is just out of habit, always include covariates, whether there's a good reason to do it or not. You're just going to do it because it makes for you think it makes for a stronger argument regarding your data, and so you're just going to always do that. I think that is a potential issue, and others think it's a potential issue, as I indicate with that paraphrase from Pethaser. And again, it has to do with if we've truly randomized assignment, all of those unmeasured, uncontrolled variables should be equally distributed, or at least not significantly different in terms of their distribution across our different conditions. And I would say that the goal is to have as few covariates as possible, and to have all of the covariates to be highly correlated with the dependent variable and uncorrelated with each other. So having covariates, if that's what you want to, if the covariate is uncorrelated with the dependent variable, it really doesn't need to be a part of the analysis. If the covariates are highly correlated with each other, it causes problems with the analysis. And so I think the goal should be, what's the fewest number of covariates I can get by with, and which of these covariates are most highly correlated with our outcome variable. And so this is the analysis, and just to have this on video, so analysis of covariance is simply GLM, and we're still doing univariate. In our case, I'm not sure that that's the data that I wanted. Bear with me, here it is. So here's the data that we've been working with. And so we're going to do analyze, GLM, univariate. And then our dependent variable is trust and media, right? Our fixed factors are female, and whether they're Democrat, Republican, or independent. We're having garage door problems at our house. And people can't get in, and hopefully everybody will be okay. And somebody needs to feed Buster. So here's our covariates. And we're just going to put those on the covariates, easy enough, right? And then one thing that you'll note, see post hoc, and remember what we do here, we select our post hoc test that we want. And when we add covariates, that's grayed out. And you can click on it all day long and it won't not be grayed out. So you have to find a different way to do post hoc test. And so we will talk about that some. But we can still request plots. And we can, under options, We can do our descriptive statistics and our effect sizes and our homogeneity test. And then if we want, do we need to do post hoc tests for female? Why not? Khalif? Two groups, right? And so there's no need. But we do for party identification, right? And then we can say compare main effects, and we can do, we have just 3 options. So you can pick one of those 3 that you like, or you could just calculate it yourself easily enough if you're so inclined, okay? And so that should be pretty close to the output that you have in front of you. And we'll talk a little bit about that output and some of the rest of this output in the next few minutes. So we can see from the ANCOVA table that several of our covariates were significant. And significant meaning what? If, for instance, education was significant, what does that mean?
Explain some of the variance in the dependent variable.
Yeah, that's it exactly. And so education made a significant adjustment to our dependent variable. Their level of interest in politics or a particular campaign didn't do that, right? It was unrelated to their levels of trust in the media, so there was no adjustment that we gained from interest. And then you can look at the other covariates as well. What do we say about pessimism? Is it significant?
Yes.
How do we characterize that level of significance? You say P is less than 0.05?
No.
Do you say P is equal to 0.05?
No.
What do you do then? Yeah, because 0.05 is the cutoff, right?
Well,
That exceeds the cutoff. Well, what?
that's stupid.
Meaning
say that,
what?
To say that, this explains 94.9% of the, or that we have a 94.5% chance of committing what is that, type 1 error or whatever. But if it's 95.0, then all of a sudden magically it's fine.
So it's not black and white. How far do we dare go up then? How about if it was 0.055? Is that still the same argument?
Depends on what your reviewers say.
What do you think, Bobby?
I would say it's not significant.
You'd say that it's not significant?
I would say it approaches significance. And then say P equals 0.05.
Yeah, I would say that it.
Well, then you can take it out.
Yeah, it seems to me that's if some reviewer quibbles about. I wouldn't say it's less than, right? You can't get away with saying P is less than 0.05, right? That just would be wrong. But you can say P is equal to 0.051. And I guess if you wanted to add in this approaches the traditional level, it's almost sort of laughable. But you could add in that little thing, but I think that might draw more attention to it than it needs drawn to. I would just say P is equal to 0.051, and I'm going to conclude that we're rejecting the null hypothesis.
I'd rather say marginally significant P is less than 0.1 than to say it equals 0.51 because you know that there's more numbers after 0.51, right?
Yeah, but it's going to round to.
And to say that it's
Well,
less
I
than
wouldn't say
Well, it
that.
might round to 0.052, right? It might round to 0.052, right?
Right.
I think that to say that it's less than 0.1.
But I would say, if I would, which I already said I
Yeah.
would say it's not significant, I would say marginally significant is less than 0.1 and hope they don't notice.
And hope they don't what?
Hope they don't
What
have
if
it.
this was like your tenure is going to be decided and you're getting this thing published?
Holy crap. I feel like saying people's .051 is so much more obvious because you don't see it as
So you would say let p is less than 0.1.
well, I would probably just not even
Why can't
mention
you
that
just
very
say
well.
it's less than 0.06?
It's 1/100.
You could say it's but why not just say it's equal to 0.051?
Yeah.
But it may not equal to 0.051 to 16 digits. Is that what you're saying, Bobby? We could write out all 16 digits.
I've
That would draw some
actually-
attention to
I've at
it.
least seen people go with the marginal significance argument where I have never seen them say.
I have.
Marginal significance, I think, would be something less than 0.01, but something greater than this value, right? So it's 0.9.
I have a stats book that says between 0.05 and 0.1 is marginally significant.
And that's,
It's
I
like
mean,
1/1000.
Not that I would go with that.
Sure.
That's crazy.
and the 0.05 is that just an arbitrary, right? That was the reason, the history behind 0.05. Has anybody studied the history behind why we have 0.05? Fisher, what was his first name? The guy, the F-test guy, Fisher, he was a British mathematician. It just happened to be, and this is what a stats teacher, I haven't researched it, but this is what I was told, that it happened to be that the page broke at 0.05 level, and so it just made sense to everything on these pages, because this is back in the old days when it was all hand, everything on these pages are we reject the null, everything on these pages we don't reject the null, as opposed to having to draw some damn line halfway through a page and then try to make that work. And so it's an arbitrary, it's right, it's not. But people, that's the good thing about the marketplace of ideas. And you, so I'm still curious about what would you do? I'm a little bit.
I was just saying if I had to include it, I would say it's marginally significant and say P is
Less
less
than.
than 0.1.
Okay.
I
Okay.
guess.
Good.
But I
Good.
would,
Good.
I would say it was not significant.
You'd say it was.
I would not even say it was significant.
You would say it's non-significant.
Close
Okay.
to be significant.
What? And so you could be making a type 2 error, right?
Yeah. So the way that I've reported it before is I might look at the means and say, well, there's a positive correlation between this variable and this variable, but it's
Yeah.
not significant at 0.05, and then I report the actual value. But I wouldn't claim significance.
But if it was 0.0,
Doctor, what?
0.050, you'd be good.
I still, I don't know if I still would.
Yeah. Okay. Good. So these are interesting questions that you'll get to as you do. You'll have to assess what makes the sense to you. Khalif?
What we use another most of tests like LSD test. Could we have another significant levels?
Yeah, LSD wouldn't change it at all, though, right? Because it's no adjustment. We could do Bonferroni correction if we thought and we could multiply each of those p-values. That would fix the problem, right? Multiply each of those p-values by the number of comparisons or the number of covariates that we have, and that would be the Bonferroni correction applied to this context. What would the rest of you do? Those of you that have more experience, not that Bobby's got a lot of experience, but other points of view. Brianna, how would you deal with 0.051?
I would mark that it approaches significance, but keep it in the analysis.
And
If it were significant.
and as if it were in claim, yeah. And I think both of those, that's the marketplace sort of sorts that out, and reviewers and readers and each of us. But you would say less than 0.1. Why do you say
Well,
less
I
than
said that
0.5?
I wouldn't even say it was significant, but then you said, well, what if
Yeah.
you're dependent on getting this published?
Oh.
Then I said, well,
Or just the next pay raise, maybe not quite so, just the next pay raise. Or your next evaluation, right? And that's what it'll be, right? Assuming you do research for a living, as part of your living, that's what it ends up being, right? It's about publication and teaching. So, it's an interesting. I think my experience is more people would probably do something similar to what Brianna said, that we would say that approach is significant. I think I would just report it as p is equal to 0.051 and conclude that we rejected the null hypothesis. Leave it at that. And then if some reviewer wanted me to change it, I could decide whether I wanted to change it or not. And or if they said, "Oh, this is bad. You're you're increasing the likelihood of making type 1 error," then I could decide whether that person knew what they're talking about or not. But we can still, from this analysis, we can conclude that we have a main effect for party identification, just as we did earlier, right? Without the covariates. Think back to last week. And we still have a main effect for the interaction. So even after controlling for those 6 covariates, is that what there is? We still have a main effect for party identification and for the interaction. Make sense? When we in SPSS ask for means here, we get these estimated marginal means, which the estimated marginal means are adjusted for our covariates. And so it's an analysis that's done that makes an adjustment for the covariates that we have in the analysis. So in this case, we might also want to ask for these two and include our female and the interaction just to get those adjusted means, because normally when you do ANCOVA, you report the adjusted means, adjusted for the covariates, not the raw means, the unadjusted means. That would be what we typically do. So we can get the adjusted means through that dialog box, which is different than the means that we get when we ask for descriptive statistics. When we ask for descriptive statistics, those are the raw means that haven't been adjusted for any of our covariates. Okay, and so in our case, we're going to get 2 sets of means. One set of means that have been adjusted, the other set of means that have not been adjusted. And so what I want to talk about now are the estimated means that take into account the covariates. And you can see in the little note that accompanies the adjusted means that it just indicates that those means have been adjusted by centering or holding at the mean value, age, and level of education, interest, and the other variables that we have as a part of the model. And so we can see that male Democrats are 3.528 for the adjusted. Male Democrats are 3.56. A meaningful difference? A meaningful difference? It's small. It's rather small, right? It's 3.53 if we round it. 3.56. And so it's not a huge difference, but it is a difference nonetheless. I don't know that we would come to substantively different conclusions about male Democrats given that adjustment. But in some cases, if your covariates have a stronger relationship with the dependent variable than these covariates, you may make substantively different conclusions with the adjusted means when compared to the actual raw means. But again, what you should report in your write-up, I think, would be the adjusted means. And you should reference them as means that have been adjusted for the covariates in the analysis. If the covariates are important enough to include in the analysis, it seems to me that the means should be reported that that include that adjustment or those adjustments. And this is just not a very sophisticated graph, but just looking at the adjusted mean and the actual mean for male Democrat, male Independent, male Republican. Not a lot of difference. Substantively, probably wouldn't draw any different conclusion for any of those three groups based on those differences in means. And female Democrat, Independent, and Republican. The difference between female Republican, adjusted and unadjusted is the largest mean that we see. But I still don't know. It's still not a different. It's not more than 1/10, right? They're both within the range of something slightly below 3.3 and something midway to 3.4. So there's not a full 1/10 of a point difference between these two. So again, substantively, would we draw completely different conclusions? Probably not. But again, it makes sense to include those adjusted means as a part of our analysis. And this would be the plot that helps us understand our interaction with adjusted means. So when you ask for a plot where you have covariates, it's going to plot the adjusted means. This is the same plot that we had last week with unadjusted means. Again, if you didn't know it, you'd say they're the same because they're just not a lot of differences across them. With this analysis, with your analysis or another analysis with covariates that have a stronger relationship with the DV, it could make substantively different graphs or interpretations of the data.
Was the slide before those two on one?
The slide before
Those two.
Yeah, the slide before it is these 6 plotted against these 6, which is the same as those means as well. Those means we'd be able to find.
Can you get those two graphed on one chart or
What two? These two?
Yeah.
Why would you want to do that?
Because looking at that, I can't see the rest of it.
Yeah, and that's the point, I think. If you were writing research or when you do the assignment for this class, you would only include this one. And this is the one that has, because if you have covariates, you're going to include the chart that has the adjusted means. I just put this one down here for display or for comparison purposes, and you write it's not very useful to look at those, but you also write again that this is that difference in maybe a little more intuitive format. So far, so good? Questions? Comments? So this is the same, might even be the same slide that we had in the notes from last week. But we really have 2 options. We can do option 1, run the appropriate test with covariates. I guess it's not the same slide because we weren't talking about covariates last week. We could run the appropriate test with covariates for the simple effects. So let's say we wanted to run the analysis for, we split the file for males and females. We would run a one-way ANOVA for with party ID as the independent variable. With party ID of the independent variable, trust in the media as the dependent variable, only for males. And then we also include all of our covariates in that analysis. That's how you would do the simple effects analysis using option 1. So you would just run the appropriate test with covariates. Again, if you include the covariates in the analysis, it makes sense to include the covariates in the simple effects analysis that you're going to do. Can you do covariates with t-test? What would you do in that case? When we flipped it around and we divided, we did Democrats, Republicans, and Independents, where we'd have to do t-test. What would you do then?
Can you still run an ANOVA?
Yeah, that's exactly what you do, right? You would run ANOVA, add in the covariates. Even though you have two groups, we don't need to do, typically with two groups, no need to run ANOVA, just t-test. But because we have covariates, so, and that would always be the case if you had two groups, single factor ANOVA with two groups, but you also want to include covariates. The best way to run that would just be to run it in the under GLM univariate with your covariates. Okay. So that would be probably the easiest way, and maybe my first instinct would be to run the simple. So I have significant interaction. I want to know, well, what's sort of leading to the significant interaction? Is it male, Republicans versus Independents, or Democrats versus Independents, or what is leading to the interaction? My first instinct would probably be to just do what would be pretty intuitive and split the file and run a couple tests to assess that. The other way to do it would be to just do it with syntax. And not that I expect you to remember or use syntax, but it would probably be easier to do this than it would be to do option number 1. And there are some benefits to doing this. And this is the top one is without the simple effects. The bottom one is with the simple effects, and these two indented lines of code are the only thing that was added. And all I did is copied this line of code here from the original analysis, and then at the very end, I added this compare statement. So I compare party ID, and then what kind of adjustment I want. I just ask for LSD. And then I compare female, and then what kind of adjustment I want to do. And that would probably be quicker to do than splitting the file 2 different times. The time when you wouldn't want to do this would be when? Yeah, and so if you have a significant Levene's test, you should use this approach and not this approach. Approach number 2. Approach number 2, you'd be violating a key assumption of it and potentially causing some other problems with your data too. But it really would take 15 seconds to copy and paste this code and copy this row from right here and add to the end of it, compare, adjustment, and then copy it again and add another compare and adjustment. And you'll have all of the simple effects analysis that you would get with the multiple splits that we did.
You copied that female times the ID, right?